Welcome everyone, and thank you for attending today's webinar, Optimize Interoperability Through In-Flight Data Quality Checks and an Integrated Monitoring Solution, sponsored by CitiusTech. My name is Mike Milliard. I'm editor of Healthcare IT News, and I will serve as your moderator today. And today we're joined by Manisha Bafna, Assistant Vice President, and Swanand Prabhu-Tendolkar, Vice President of Data Management, both from CitiusTech, who will share their perspective on data quality issues and the need for integrative management of interfaces. And Manisha and Swanand will impart their wisdom about the struggle large health organizations face while trying to manage multiple integration engines and effectively monitor servers and data interfaces. So with that, let's get started with our presentation.
Hello everybody, this is Swanand here, and Mike has already kind of talked about us, so I'll skip this introduction slide and move to the next one. So webinar objectives for today, we are looking at interoperability trends that are there currently happening. There are shifts that are happening in the market. The challenges that are faced by organizations in achieving their interoperability goals. So if are they facing challenges in terms of receiving data? Are they facing challenges in terms of the quality of data? Are they facing challenges in terms of monitoring their interfaces? For various reasons it could be, and we'll go through all of them. And then of course the next one is the importance of data quality and monitoring. One of the biggest thing that we have been seeing at CitiusTech, whenever we talk to our customers, each and every customer is telling us that yes, they are facing trouble with data quality, the kind of data that they receive from various sources. And in fact, nowadays, if you look at the world, there are just too many sources that keep getting added. Earlier, there were probably EMRs. The labs came in, various other systems that keep coming in, and then slowly we got into the world of wearables and devices and whatnot. And then quality of data started becoming even a bigger problem. And the reason is that if you don't have the good quality data, then your KPIs and your assessments and all the analysis that you do on top of that, that kind of goes for a toss. That goes without saying. And then what is the CitiusTech's point of view? So what are we thinking about it, and why are we thinking about it? So most of our customers kept telling us that while we receive data from the multiple systems, can we do some sort of a check in terms of data quality before I push it to my area? So whether I'm getting into my repository, whether I'm getting into my data lake in the newer phases, or whether I'm sending it somewhere else, or whether I'm writing my KPIs on top of it. But the problem that they face is they all have data quality checks, but that usually happens after fact. Once the data is in the data repository, it goes in, gets curated, and at some point in time, maybe 5 days, 10 days, or maybe even a month later, they come to know that the packet that was received at some point in time was not correct, and can we do something about it? And that's what we were thinking that we should come up with. And we have a point of view on that, and that's what we are going to discuss. This is the agenda of today's discussion, current scenario and challenges. I will kind of talk about that. The data quality and monitoring overview. Manisha would take that up. Features of an ideal solution, what's our point of view, and then we'll conclude. Okay, coming to interoperability current state, these are some of the numbers that we looked around, we did Googling around, and we figured out what are the different challenges that people are facing. You can read the number for yourself, but if you look at it, most of them are talking about they feel that the quality of data that they receive is not really good. They feel that the bad data that is currently sitting inside their repository is really huge. You can see that it's 74% is what people are feeling the same. Around 90,000 lives are lost every year due to medical errors, and medical errors caused by poor quality of data. There are many other challenges in terms of monitoring as well. Many people have multiple interface engines, multiple ways to get data in, and they face monitoring challenges because For every way to get the data in, if you have interface engine, maybe you have in big data you have Kafka. Everybody has their own way of monitoring it, and you don't have a single pane of glass, and they all face trouble. IT tools, everybody uses multiple tools for monitoring, and there is a chance that you might miss out on one of them. In real time, are those tools giving you what's happening across all your systems? Currently, they are not. Most of the people are feeling that yes, there is a lack of single view for all the monitors, and that's kind of hindering their operations because they are not able to take the right decision right time. If one of my source is sending me bad quality data today, can I go to my source and tell them, okay, you are sending me now, and stop the feed? Please make changes on your side and give it back to me. They are not able to take this kind of decisions. That's what the numbers also say, and when we talk to our customers, they are also feeling the same, and that's the current state in which we are. Moving on to the next slide. This is a typical ecosystem that we have. There are multiple sources. EMR, HIs, these are all usual suspects. The lab management systems, PMS and HIS. There are billing systems and, yes, the new ones that are IoT devices and wearables and whatnot. There are many different types of format in which data keeps coming in. Earlier we had HL7, then we had CCDAs, QRDAs coming in. For billing we have X12. For wearables we probably get XML, or sometimes we get JSON, and nowadays FHI are also coming in. And we usually would have an interface engine with a Mirth or Rhapsody or Ensemble of the words. And what they would do is they would kind of have these receiving ports. They would get the data from various places. That's what the integration and a data acquisition job they are made to do. The next one is transform it to the target systems. Sometimes they would just pass it on to the subscribers in a HI kind of a setup, or they would push it to their repository. Maybe they would send it to their Edifax or maybe claim adjudication system if it is hosted by a pair. So this is the way the typical interoperability system works today. The general features are always to expose an endpoint for integration, and then there are a lot of configuration that you have to do, and then on top of that you will have transformation and then send it across to the downstream systems or to the subscriber of the messages. Although integration indeed handles source to destination transformation and all, what it kind of doesn't do currently is it doesn't really look at the data quality. It doesn't really snoop into the data. It looks at semantic checks. It looks at things like whether the HSN message is well formed or not, whether the PID4 is it really coming at that place, stuff like that. But it doesn't really check the data. It doesn't really check the relevance of the data across multiple entities that are given that are sent in a given message. And effective monitoring. So monitoring source traceback, multiple of them are at once. They kind of don't do it, and that's the thing that we are going to talk about how we envision that we can solve it. Going to the next slide, the interoperability challenges and solutions. We talked about some of them, but if you look at there are multiple data interchanges standards. And integration engines currently do a very good job of it. They all can parse HL7, FHIR, CDA, DICOM, EDA, come what may. They are very well geared to parse all standard healthcare data formats. Multiple coding terminologies and terminology transformations. Integration engines do a good job of that as well. Multiple data element definitions. Yes, they are made to do that as well. The last two ones, poor quality of data and monitoring and audits, that is where they kind of do not so good job, I would say. I'm not going to criticize them saying that they are not doing even good, they are doing bad job, but not so good job, because they don't really snoop into the data and they don't really talk to each other if a given organization has multiple interface engines. And that's the kind of challenges and the solutions that we are seeing. And the last two ones, poor data quality and monitoring audits, are the ones that we are going to focus for our today's discussion. Moving to the next slide, and we are going to come up with polling questions here. So what do you think is the biggest challenge in the interoperability system today? Is it multiple standards, coding system terminology definitions? Is it the data quality that you are receiving? Is it the monitoring that you have to do? Or is it something else? Just the technology is not good, or just the way you are receiving data is not good. It could be just about anything. And I'll just take a 5-10 minutes pause here and then probably move forward. Oops. Okay, this slide we kind of saw, but as I was seeing that the polls, many people were saying that they had trouble with the first two problems. That is, okay. I'm really sorry. I got into the next slide by mistake. Okay, so this is where we are, and when I looked at the polls results, many people talked about the first two problems, the multiple terminologies transformations and the data quality were the two winners in terms of the problems that they face. And for today's discussion, as I said, poor quality and monitoring audits are the ones that we are going to focus on. And let's move to the next section, and I'll hand it over to Manisha to take us through the data quality and monitoring overview, how it is to be done. Manisha, over to you. Slide 12 onwards. It's you to take over.
Thank you, Swanand. Hello everyone. I'm Manisha Bafna. So, so far Swanand, gave an overview of, perspective on how interoperability ecosystems are working today in terms of data quality, in terms of data monitoring. What I would like to cover is, what is the typical, considerations we need to have when we are looking at data quality, when we are considering data quality in a data management framework, in a framework where there are multiple systems interacting and exchanging data. So, if you look at the slide, right, I mean, we've tried to categorize, based on our experience, right, the most common elements, or I would say categories that you need to worry about when you are, setting up a data management framework. You are setting up, data extraction layers to get data from different types of sources, right? You need to worry about standard or most popular scenarios of data quality. That, okay, do I have a provision for missing data? How am I going to handle my null checks? How am I going to handle parent and child relationships in the data that I'm going to get? For example, if I'm getting a patient demographic data and I'm getting a medical record data, do I have enough checks and balances to link those two records? All right. What do I need to do if I'm getting invalid data, fat finger data, right? What kind of data transformation or data cleansing strategies I need to worry about? How do I aggregate data where I'm getting data from multiple sources for multiple records of the same scenarios? Or how do I do a cross-field check, right? Data validation across multiple entities. So I may be getting multiple medical records for the same patient, duplicate records for the same patient. How do I keep check of that? How do I reconcile the data? What would be my reconciliation strategy? Would it be something where I need to manually rely on some clinical experts to reconcile the data, or do I do auto reconciliation and then go for sign-offs, right? I need to think of all those different kind of scenarios when I'm handling the quality of data, when I'm extracting it from disparate sources. So, moving on to the next slide, it's again another poll question. Sorry, I'm not able to move to the slides. Yeah.
I'll make the movement.
So, thank you, Swanand. So, while I was just setting the context, right, I know this second poll question came up sooner. So, just in that context, right, what are the type of data quality issues that your systems are handling every day, right? How many data quality issues do your systems handle today? we just wanted to know that. So, okay, the polling is happening right now, and looks like, okay, we'll just give it a few seconds. And definitely, we see that there are about, at least 0 to 50. The first option takes the cake. Most of them are saying that there are at least 50 data quality issues that the systems handle on a daily basis.
Okay, I'm moving to the next one, Manisha.
Yeah. Yes. So, while we are worrying about the data quality checks that we need to put in place, right? Even though there are we do define our data quality rules, we do worry about how we're going to handle null checks, missing fields, and all, right? But still, right, today there are the health systems do face issues around data quality checks, right? So whether it is incorrect syntax, my receiver is expecting the data in a certain format. So even if my data is correct from the source system, for example, I may be sending the gender coded as M, but my receiver is expecting it as male, right? So this is a very simple example, but there are complex scenarios where even if the sources think they're sending the data in the right way, the receiver is expecting it in a different format. So day in, day out, Interop systems, they face these issues. There are data analysts who are sitting on the data, trying to fix it, trying to correct the mappings. And yeah, I mean, the integration engines today provide a lot of provision to take care of the mappings, but we still have those kind of issues. Similarly, incorrect formats, there are still data which is missing, for example, the claims data or the patient demographics data, the data gets rejected because in the receiving systems because you were not getting the data in the format that the receiving system was expecting, or there could be certain fields which are not mandatory for my source systems, but receiving systems are expecting that information, right? And you do face these scenarios specifically, when you're sending data in an HL7 format, right? Similarly, there's mismatch in the data. There are some fields which are not utilized or the fields are not making sense. For example, you're sending a date of birth as the year as 1988, but the age of the patient recorded is 40, right? So that the math is not matching. There's some problem with the data in that kind of scenarios, or there are dependencies in the data. So you're getting some visit data, but the related diagnosis data is missing. You'll not be able to do any kind of analytics, or my billing systems will not be able to do any kind of medical coding on that if I'm not getting the data the way I was expecting it. So these are very common data quality challenges today, even though we have, well-defined formats like HL7, and now FHIR is coming up. We have CSVs, we have Excels, we have the senders and receivers doing enough handshaking during the discovery phase, deciding on what is it that I'm expecting. But these are still, these challenges still, prevail today. And a lot of time is spent during when the interfaces go live. The data analysts are spending time in fixing these issues. So if you move to the next slide.
Yes.
So what is important is, right, for us to ensure that, see, the most common challenge today the Interop systems faces, there's a lot of backlog. There are too many trading partners, too many health systems who want to go live with the interfaces on, let's say, practice management systems need to interact with EHRs, revenue cycle systems need to interact with EHRs. There are lab systems who would want to, integrate with radiology or other EHR systems, right? The backlog still remains, and it's important that you are worrying about the data quality checks well in advance, right? So that the time that is spent in taking the interface live and the time that is spending in monitoring or troubleshooting the interface is less, right? And you are able to, work on your backlog and expedite the onboarding of interfaces. So data quality check plays a very important role here, because the moment you're worrying about the completeness of the data, you're worrying about the validity of the data, you're worrying about the accuracy of the data, right? A lot of your challenges, a lot of your real-time issues on fixing the data would be solved. So when you are strategizing your data management design, or you're working on your data interoperability design, think of these 5 to 6 important data quality parameters. Think of what would you define as a complete and accurate data. Think of what would you define as a unique medical record. Think of when is it that you need to get the data in the right format, what is the time check, real-time data, or data coming in batches, right? So these are very important parameters when you are designing your data management or your data interop strategy. So yeah, and while we're thinking of completeness, accuracy of the data, right, I would just like to share, what is our opinion about how can you achieve data quality, and how can you proactively think of, managing or designing your data quality strategy, right? So so simple things, right? Making sure that how do you analyze the data that you're getting from the source and improve the quality of the data that you're getting from the source based on your historical experience. So for example, today if you know that you are interoping with practice management systems and you're expecting the data in the EHR, right? If you know that there is a certain practice management system which is a problem area most of the times, right? Try to think of, look at some source quality trends. Try to, trend that, sorry, my mic just came off. Try to think of scenarios where I know that this is a problem source and I need to proactively, worry about the data quality that I'm getting from the source, right? So how do I do it? I historically trend the data. I give enough feedback. I provide training to my source teams or my data analyst team such that these issues, I'm not spending a lot of time in fixing repeatable issues, right? Similarly, try to define your data quality rules well in advance and code those rules in your integration engines, right? Run those rules through your databases and then have electronic trend of those records such that, you're proactively catching some data quality issues right in flight and not reacting to that once the data is moved to the downstream systems and then, worrying about correcting the data. Similarly, try to monitor the data. Today, there are a lot of dashboards, even the integration engines provide, where you can, look at the trend of the data that you're getting from your sources. You can, develop your own rules and define those rules in your integration engines. These engines provide a lot of scripting methodology to you can actually code your rules in the integration engine and reject all the data which is of not good quality, or do a parallel processing of that data and let the sources know in advance, or have a proactive strategy to fix that data instead of worrying about it once the data is moved to the downstream systems. However, while you're thinking of that strategy, there are certain drawbacks. Large health systems today have multiple integration engine tools. Then you need to have specific dashboards, specific KPIs that are trending in your dashboards. These type of reports do not come out of the box from the integration engines. You need to design your own dashboards. You need to make sure that the process is less cumbersome and it's not overwhelming, and your focus from developing exchanging the data, right? You shouldn't be moving your focus from your core strategy of exchanging data to fixing the quality issues, right? So it has to be a parallel process. But your error identification strategy has to be less time consuming, has to be less reactive. So it's about maintaining that balance on proactively thinking about the data quality issues and trying to use the integration engines to the best of their ability, right? Such a way that you could code for the rules even before the data is transformed and moved to the systems, and then you are able to trend your sources, your most problematic sources, and giving enough feedback, giving enough training to your data analyst, engineers, and to the source systems.
Should I move to the next one?
Yes. So while so far we were speaking about data quality, making sure that you have a proactive strategy on, ensuring that the most popular issues are, captured in advance. What you also have to worry about, right, is doing the active data monitoring once the data is moved to the health systems or while the data is moving to the receivers, right? So the typical, so today, right, large health systems have a dedicated support team which is only monitoring the interfaces, which are responsible for exchanging data from source to receiver. These teams, dedicatedly monitor the, they do the server checks, they do the CPU disk performance checks, storage check, they look at the connectivity, they make sure that the messages are being, received by the downstream systems the way it was expected as per the schedule. They make sure that the messages are not just lying in the, in a certain folder and not reaching the databases. They make sure that the interfaces are connected. There are no issues with SFTP or web services, or the databases are not down, right? So these teams are dedicated to just ensure that, the interfaces are working as expected and the downstream systems are receiving data as expected, right? But few challenges that these teams face today is, right, and I gave a little, I was speaking about it a while ago, right, that large health systems today have multiple integration engines. It could be by the virtue of fact that these health systems have multiple business units and they have their own preferences, or it could also be a function of, the hospitals or the health systems getting acquired by a larger health system, and you're still, using your preferred integration engine vendor, right? So most of these guys today may have a Mirth, a Cloverleaf, a Rhapsody, and they could have multiple types of deployments. Like they could have some servers running on premise, some servers running on cloud, and it's a very common scenario these days, right? But the challenge that this scenario brings on the table is that the support teams, right? The support teams are not expected to function and have the expertise across all the tools at once. So you may not have teams who understand Mirth and Cloverleaf very well, and there can't be a central team who knows all the integration engines very well and who has knowledge of all the different types of interfaces to monitor. Right, so that is a scenario where the teams are using multiple tools. The teams are spending a lot of time in monitoring the interfaces. The ticketing, the response time gets impacted. There are multiple dashboards to look at. There are different ways of solving the issue. There is no central team who is thinking of managing this effectively, right? And then you're writing rules in a certain scripting language. So today I have written some data quality, some data transformation rules in Mirth. Let's say if I have to migrate my systems to Cloverleaf, Cloverleaf has a different scripting language. So I'll have to recode all my transformation rules if I have to migrate my interfaces from Mirth to Cloverleaf. Similarly, the integration engines, while they do a good job of, providing a lot of default capabilities in terms of transforming your HL7 data, validating your HL7 data, right? But still, they don't provide a detailed troubleshooting mechanism to trace back your issues back to the source, or, exactly trace where the issue was in which server. They would give you high-level insight, but the interface monitoring team literally has to spend a lot of time looking at the logs, figuring out which server had a problem. Was it an on-premise server? Was it a cloud server? And then accordingly reach out to the right person to solve those issues, right? And this is only building up. Okay, given that systems today are also using different types of formats. There are systems who are going to move to FHIR. There are systems who are still on a CSV format. There are systems who would be sharing claims data in EDI format. So multiple formats, multiple integration engines, multiple tools, and hybrid deployments are only making the data monitoring process complex and, difficult, right? So, if you move to the next slide, right, to conclude what I'm trying to say, given that these data monitoring challenges prevail, right, we wanted to understand what is the most biggest challenge that the health systems face today, right? What is your opinion on the biggest challenge in data quality and monitoring? Is it lack of centralization? Is it because there are multiple tools? The source data is poor, correcting the errors, you spend a lot of time there, or anything else that you think is a biggest challenge?
Okay.
So it looks like a combination of, looks like a combination of a lot of the scenarios that we were touch basing on. So I'm glad that the audience is on the same page as us. So yeah, we can move to the next slide. Yeah.
Okay. So we will just look at, we are calling it an ideal solution. I'll go to the slide. But for that matter, we can call it a comprehensive solution, or what is it that we think could be the good one. Okay. So ideal is the word that we are using right now to make the point here, but you can read it as comprehensive or all-encompassing or whatever. What we're thinking of it is we're trying to overlay the diagram that we saw some time back, how the current typical scenario looks like. The sources still remain the same. The job that interface engine does, still in the gray, the transformations, configurations, integrations, that doesn't go away anywhere, and those general features are still there. And then we are thinking that we can have the data quality rules itself embedded out there. And those could be integrated dashboards, and those should be interface engine agnostic statistics. So how does that will happen? Think of it as a situation where we have something, correct, my own agent, my own component, my own hook, or my own probe sitting inside the interface engine. And what it's doing is it's a low footprint thing, and that's where the ideal situation comes into picture. It's a low footprint thing which will sit inside my interface engine, and it's kind of doing the job of gatekeeper. Interface engine is my gateway to the world, and as the data keeps coming in, it's going to look at the data that is coming in. It would do some amount of parsing in order to get the data out of it. So if we need things like the patient's demographics, or maybe the diagnosis codes and things like that, what we can do is just do a little bit of parsing or figure out those fields, and then run data quality on top of it. This is what we think we can do, and this agent which is sitting inside the interface engine is going to help us out. What it also helps us doing is, what will also help anybody doing is, if I have got multiple interface engines, I will have this my agents or my hooks sitting inside multiple interface engines, and they're still going to do the same job. So my Mirth receives HL7, my ensemble receives EDI. My agent understands that this is ensemble, it gets data. It understands it's Mirth, it has to look at channel. If it's Cloreleaf, it has to look at what's called as interface and whatnot. It gets the data, and it will perform what we call as a data quality check. It will also consistently look at the things like health of the system, health of the server. If I have got multiple Mirth engines and multiple servers on which the Mirth engine is deployed, it will also look at the server health and keep publishing that data. And at the same time, my agent sitting inside Ensemble also doing the same thing. And then there will be a centralized dashboard. And the integrated dashboard that we mean is the one which is going to bind all of this together, the data quality, the monitoring aspects of it, monitoring aspects of both this servers, both the interface engines and all the underlying servers. It's going to get all of them at one single place and show the dashboard to my administrative team. They don't have to go to different interface engines for different problems. I have to look at HSM's feed, just come to this integrated dashboard. I have to look at EDI feed, just come to this interface engine dashboard, the integrated dashboard. That's what in some ways we are looking at the conceptual level, and we'll also look at in little later how this can be made possible by a technical solution around it. The easiest way to think of it is this is the one which is my hook, or the agent is going to send data to an external party, a web service, and that web service is going to do all the hard work of figuring out data quality, all the hard work of storing all the information that you have received around the monitoring. It's going to do all the hard work of storing it. And that web service or that service, be it RESTful or not RESTful, is going to do all the hard work, and that's going to be agnostic to my interface engine. And that's the reason why we had been saying that my data quality checks and my data monitoring single pane of glass has to be interface engine agnostic. It's a third party which is going to do the job, and then that thing will also have things like a GUI to create your new rules if you want to create, you want to deploy new rules, you want to make certain rules not to run today. All of that thing should be done outside this, and the hook is only going to do the very low footprint job of looking at data and sending it to the third party. Going to the next one, an ideal solution would have a GUI-based rules management. We definitely believe in the fact that all your data quality needs keep changing, and you don't want to go to developers every now and then. I want to add one more rule. You just need to have a nice GUI-based data quality rules management, which is going to create the new rules for you, which is going to apply those rules to your various interfaces that you are getting data from, and it's going to deploy the same things as well. And at the end of it, it's going to execute those rules against the data that you get and give you a nice dashboard out of it. This kind of ensures a high configurability because everybody can use it. And it's complete auditability. Every message that comes in has to go through a certain amount of data quality checks, and it's going to audit each and every message against what happened when I ran the given data quality check against it. Going to the next slide. These are the potential use cases. This is a kind of a busy slide, so forgive me for that, but I'm not going to read through all of that. First is granular message validation. Yes, you want to look at a little bit more than just the semantics. This is possible. Second one is a detailed source traceback. Yes, for each and every error that you are getting for data quality, you can do a detailed source traceback, not just pointing to this TCP/IP instance, but to actually EHR, because when you're doing this configuration against the given channels, interface engine understands it as a channel, but when you're doing this job to third party, out there you can definitely do a configuration stating that this channel is the one which is giving me data from this particular health system. So you can actually tie it back to which health system has sent you that thing without worrying much about it. All of that information will be available. Currently as well you can do it, but you have to do the tracing a little bit, getting into the details of it. Here you can map everything at once. The multi-interface configuration, yes, because your data quality rules are not really written inside the interface engine, and each interface engine would have multiple interfaces. Somebody sends you ADT, somebody sends you ORU, and you want to have different kind of quality checks to be performed on ADT and ORU. Yes, you can do that by applying different data quality rules for the different interfaces that you have. The next ones are real-time quality analysis. Yes, as and when the messages are coming in, we are looking at the quality, and it can do a real-time reporting. So since today morning, which interface, which source is giving me grief in terms of which data quality issue, it should be able to do that. Pre-configured rules, Manisha talked about. I'm not going to talk much about it. The last one is quality as a service. This third-party thing which I'm talking about is the one which you can use for just about anything, not just here. This is one application that we thought the hooks are going to call this service, but you can definitely make it quality as a service for your enterprise. Anybody else wants to check the quality of data, they might as well call this service even if they are not using interface engine, because you now have a comprehensive service that is developed which is going to check multiple data quality rules on the message that you sent across. You can definitely use this as your quality, as your service or a SaaS offering, which is going to show you the data quality. So these are the potential use cases that we thought of. The ideal solution is going to provide to you. Going to the next one, Manisha, over to you. If you can talk about how the solution is, and she will also talk about the CitiusTech way of solving this problem, and then we'll go forward. Yeah, Manisha.
Sure. Thank you, Swanand. So actually, I'll not spend a lot of time in the slide that has been presented because, in some ways, Swanand covered what an ideal solution would look like, and without a solution, right? What is the current state today? A lot of redundant processes, lot of most of the time it's a reactive approach to handle the data quality issues. The development of the coding of the KPIs is ad hoc based on the need. There's a lot of effort that goes into fixing these issues. There is no insight into poor source trending, and a lot of manual troubleshooting that happens, a lot of dependency on the existing team, right? Right from the time when you are onboarding an interface till the time you are monitoring the interface, right? If you don't have a solution which is proactive in the way you're solving your data quality issues, empowering your product owners, your data analysts to define the rules in a central place, having one stop shop where you have access to all your data quality insights, all your data monitoring KPIs, right? It's very important that you have that solution in parallel, which is only focusing on data quality and data monitoring, giving you additional insights in a situation where there are multiple health systems, different types of tools that are being used, different types of skill sets that are required to manage these interfaces effectively, right? There is a need for a solution which is only focusing on this, while the standard teams worry about exchanging data from one source to another, right? You need to have this parallel solution which is only focusing on data quality and giving you additional insights on your servers, on your messages, on your interfaces.
Yes, Manisha. I'm on the
right. So the way CitiusTech is trying to solve this problem today, right? And we've been working on Interop projects since a decade, and based on our experience, we thought of launching a solution, right? A platform called H-IQM, Interop Quality Monitor, which actually comes up with a pre-built set of data quality rules across different types of formats. And we've actually collected all our experience in the past decade to exactly know what are the different types of HL7 data quality issues that the customers face, what are the CDI, what are the EDI issues. And we're also incorporating FHIR, given that FHIR is going to be, taking up a lot of this Interop systems, right, moving from HL7 to FHIR. So we tried to collate all these different types of data quality challenges and issues into a pre-built set of quality and monitoring rules. We tried to come up with a rules management solution which will empower the product owners and the data analysts to define the rules, to configure the rules for different types of interfaces or the health systems that you're going to develop, right? And keep it agnostic or independent of your integration engine. So today, if my health systems want to move from integration engine A to integration engine B, or they want to, manage multiple integration engines, right? The whole data quality and data monitoring piece would be agnostic to the integration engines. While the integration engines would do a great job of transforming the data, configuring your interfaces, and transforming the data to your receivers, to your downstream systems, this solution would only focus on data quality and data monitoring, and it will work in conjunction with your integration engines. But at the same time, it will be a central solution which will give you a lot of insights, which will help you expedite your interface development and reduce your backlog, reduce the amount of troubleshooting that the data analysts have to do manually today. So if you move to the next slide, right, it just gives you a sneak preview of how we've thought of the solution. So while you have your different, and we've tried to keep it agnostic to the most popular integration engines that we have today, right? So we did a survey and we found out that most of the systems today prefer Perth, Cloverleaf, Ensemble, Rhapsody, and then there are systems who also have CorePoint and other integration engines, right? We have basically tried to fit in this platform within these different engines, and then it will be a parallel process that would generate all your data quality insights. It will report all the data quality errors while the integration engines are transforming the data, and then it will give you additional insights on your monitoring interfaces. It will give you additional statistics which the integration engines will not provide out of the box. It will give you smart search capabilities to look at the issue type, to look at the server name, to see which environment it is in, and it will also give you a capability of creating and defining your own rules. So you are learning while you are monitoring your solutions, and you're making your data quality and your data monitoring strategy better by having a GUI, by having dashboards and insights, which gives you a better view of how effective your data quality and data monitoring strategy is. So, I would just conclude. Yeah, go ahead, Swan. You were saying something?
Yeah, just go to the next slide. That's
we are
kind of
so
10 minutes
right.
We are left, so we need to give some time
Correct.
for the question. So I'll go to the next slide, which is the conclusion.
Yeah.
Yeah, and if you can talk through that, and then
so
we can.
This is basically correct. So I'll just conclude what we've learned today, right? So as Swanand and I were talking about what is the current state of interoperability, worrying about data quality and monitoring, right? The use of multiple integration engines, the fact that the team spend a lot of time manually fixing issues, the fact that there are multiple formats preferred by the sources, the fact that there are multiple expectations that the receivers, the downstream systems have in terms of the way they would like to see the data, right? So there are challenges around the standards, there are challenges around terminologies, there are challenges around the way you are doing your data quality and monitoring, right? The key takeaway is that try to think of a proactive strategy to catch your data quality issues in flight before the data is transformed and moved to the downstream systems. Think of, effective dashboards and insights and methods where you can, look at the data, learn from the data, and, modify your strategy based on that. So, have an integrated monitoring solution, agnostic to your integration engines, be ready for the change, right, that the health systems would have, and keep this data monitoring and data quality completely agnostic to your Interop health systems. So with that, I'll take a pause, and, Swanand and I are, open to take up any questions if anybody has.
All right. Thanks to you both for a very informative presentation. And we do have some questions already. We encourage you to add some of your own, and we'll get to as many as we can before the top of the hour. But first up, and I guess I'll just throw this out to either or both of you, someone's wondering, does the proposed approach work for a repository kind of solution?
Manish, I'll take this up. So
sure.
What we're looking at here is more of a streaming or an in-flight kind of a data quality. And we are trying to but we are trying to solve the problem of data quality even before you ingest into your repository. So let's say, and let's take an example and let's make it pretty much real. So today we receive an ADT message for a patient for a visit, and we look at the data quality of that ADT message. It could be looking at things like the visit date being greater than the date of birth, and it could be as trivial as that, or it could be even difficult as the patient's diagnosis matches with the gender or not, and things like that. It could be just about that. And maybe after a few days we receive an ORU message, or maybe after a few days we receive RGB message which is talking about medications. And maybe ORU message is the one which has some data which is not in agreement with the ADT message that we had received maybe a few days back. This particular solution may not be able to do that because it is something which is going to look at ORU message as an atomic message. It's going to look at the data of ORU message and it's going to tell you, okay, what's wrong with that message. But something that you need to, if at all you have to look at something which is going across messages, then this is a streaming solution trying to fix the data in flight within that particular message before it makes its way into repository, rather than sitting in the repository and now look at is it really fitting with the other data or not. So it really doesn't do that. It does more of a in-flight thing and not going across messages.
Okay. Another question here. Can the solution be used over any integration engine, even custom ones?
Okay.
Yeah, Monica, would you like to take that?
Yeah. Yes. So the question is, if this, can the platform be used over any integration engines? And there could be scenarios where there are custom ones. So the way we've thought about this is right, and I'm assuming this is specific to the platform that I spoke about a few minutes back. We can definitely use this for any kind of integration engines. As I was saying, we've developed this keeping in mind what are the most popular integration engines today, right? So the 4 to 5 engines that I spoke about, MERT, Cloverleaf, and so on and so forth. As long as there is a capability of developing, so what we're trying, our strategy is that we will develop a hook or an agent which will sit in the integration engine, whichever integration engine the health systems will bring on the table, right? And as long as that engine is being deployed in the integration engine, we are good to go, right? So to give you an example, we have developed some 4 to 5 agents today which comply to the existing integration engine scripting languages, right? And we deploy those agents within these integration engines, and then we are able to view the data, extract the data, and perform our compliance checks on that. So if somebody brings in a custom integration engine, there might be an effort to develop a custom agent, and the rest of the design remains the same. So it won't be too complicated to do that as long as we are able to develop a complying agent which fits into the integration engine. So I hope I answered that question.
I think so. Yes, makes sense. Thank you. Someone else is wondering, does the proposed approach address monitoring only, or if it does it address monitoring only, or if it helps correct it as well?
Okay, I'll take that up. So the way we have imagined this is currently monitoring, and corrections are the ones which are a little bit tricky, in fact. And I'll come to why they're tricky. So the source system sends you data, and then you correct it in flight before you push it to your repository. What it, in a sense, means is that there is a disparity in the data that you have and the data that is there in your source system. The source system has something else, and you have something else. If that kind of situation has to arise, we at CitiusTech feel that data correction needs to be done by the sources. Having said that, there are certain kind of transformation or certain kind of corrections that you want to do, you can do it. So as Manisha some time ago talked about, somebody sending you gender as M, you want to make it male. These kind of standardization corrections, or somebody sending you maybe a different kind of a header, and which is not really expected, and you really want to ignore that header and go ahead. Maybe that's kind of a thing you want to do. Fair enough. So anything that doesn't really change the parity of the data between the source and the target, we feel that that can be done in flight. But we kind of feel that if the parity of data is going to change, then that should not be done in flight, because the source has something and you have something else. And if at all you need to get into some sort of audit against the data that is there in source, against the data that is with you, it will be a difficult situation to handle. So currently we are thinking that yes, do monitoring and do correction to the extent of doing standardization stuff, but not really changing the data as such. What it can also do is it can, if there are certain quality rules, and what you can tell is if this rule is flouted, don't let the message go ahead. That is something we can do. So current monitoring means we just monitor and let the data flow. But yes, if you want, you can stop the data flow as well. So the way currently we are able to stop the data when the semantics are not met, we can do the same thing if the data quality is not met. You can stop the flow of that particular message. The service can send that, okay, there are high priority data quality rules are flouted in this particular message, and please don't let it move forward. So something like I receive gender as female and I receive one of the diagnoses as prostate cancer, and maybe that is something which is just not acceptable. So what can happen is we can say, okay, stop this message flow, because the kind of quality rule it has flouted is a really high quality, high priority one. Certain things you can say, okay, the low priority they can keep moving. So stopping message flow is something which is fair, but changing is something we shy away from it.
Excellent. All right, well, we are just about at the top of the hour, so I think we will wrap up. But I want to thank you both once again, Manisha and Swanand, for a terrific presentation. And thanks, of course, to the audience for joining us today. Please be sure to complete the evaluation at the conclusion of the event. That will be just popping up on your screen to share your thoughts with us. And as a reminder, today's session will be available on demand for 1 year through the HIMSS Learning Center. Thanks again to everyone, and have a great day.
Yeah, thanks a lot, everybody, and thanks for being patient with me.
Thank you.